Hello, welcome to India's most comprehensive e-learning platform BYJU'S Exam Prep, and also special welcome to electrical and instrumentation students for this wonderful series. As you all know, currently we are here to discuss the previous year questions on the subject called measurements. Of course, this is the second part related to the measurements. Yesterday we have discussed some of the concepts related to previous year questions, especially in the measurement. That was part 1, and today we are here to discuss the part 2 of the measurements. Those students who missed the previous part, I sincerely request, please watch the lecture part 1 first and then come to here. However, even if you attend for the very first time here, you will be able to understand, but don't miss the questions which were asked from the part 1 also. Clear? Well, moving ahead, as I said, before going to the discussion, let me quickly introduce myself to the new students. My name is Phanindra. All put together, I have an experience of 11 plus years. So far, I have guided more than 50,000 students in the subjects of control system and circuit theory, measurements, as well as industrial instrumentation. And I am especially known for industrial instrumentation. Moving ahead, as I said, we are going to have marathon session that will be sharply starting from the tomorrow. However, the introductory lecture will be there at 10 p.m. sharply today. Those students who want to enjoy the marathon session of each and every subject, stay connected to the BYJU'S Exam Prep channel. As I said, 10 p.m. we will be on live and we will be giving the complete route map for the marathon session. Of course, as you know, marathon session is going to be a special premiere on YouTube channel, especially from the BYJU'S Exam Prep time. So at any cost, please don't miss the marathon sessions. However, today at this point of time, let me deal the questions related to measurements, that is part 2. Okay, so moving ahead, yes, one more important news to every one of you. So of course this workshop is completed. So let's straight away get into the topic of DC and AC bridges. As I was repeatedly saying that we are currently here to discuss the remaining part of the measurement. Already we have discussed about error analysis as well as PMMC, moving iron, electrodynamometer and wattmeter related questions in the previous lecture that was handled in the yesterday session. Today we are going to cover the remaining portion like DC and AC bridges. Followed to that, we will also see questions on CRO, Q meter and even DVMs, and at the end I will also cover the CT and PT, that is current transformer as well as potential transformer. Clear? So let us start the first question of the day. As you can see, the number is given like 15. Why it is so? Because in the part 1 I have already covered the first 14 questions. Okay, so technically this may be 15th question, but it is a continuation of the previous portion. Clear? So let's get into the topic directly here. This question was asked in the Instrumentation 2022 paper. The statement of the question is like this: the resistance of a pure copper wire of length 10 cm and diameter 1 mm is to be measured. The most suitable method from amongst the choices given below is dash. So this means you are provided with the 4 options and you should select one of the best technique that is used to measure the resistance. What you will select? Obviously, see, 10 cm length and 1 mm diameter. So that means I can quickly say that resistance is equal to, as you know, that can be written as rho into L divided by A, as the length is less and the area of cross section is also less. So I would be saying, in fact, I would be calling here the overall resistance is less. So when the overall resistance is less, such a small diameter here, right? So therefore we will go for the 3-wire method, right? So please keep this point in your mind. Whenever we try to measure the low value of the resistance, we go for the 3-wire RTD, 3-wire method. In fact, Kelvin double bridge kind of things we will use especially to find out the low value of resistance. Now moving ahead to the next question. So next question, of course, yeah, this is the question, and this question was asked in IN 2022. This is also a simple question. Of course, I do agree that this is a theoretical question, but I need to solve this as it was asked in the Instrumentation 2022 paper, that is recent, this year paper, I mean previous year paper. So in which of the following bridges is the balancing condition is frequency independent? Very good. So see, he himself told very clearly, given in the question, bridge and inside the bracket yes. That means there may be a possibility that more than one option may be correct answer for this question. That is the clue from the statement of the question. Now you see, you require the bridge balanced condition, and that must be frequency independent. The term frequency independent plays a dominant role in the AC bridges, right? So first of all, straight away I can remove the Wheatstone bridge, because most of the time when the Wheatstone bridge is given means it is for DC. I am not saying that Wheatstone bridge is technically measured or used only for DC. We will also use the Wheatstone bridge configuration for AC also. However, as it was mentioned like this, remaining all bridges also there, so I am considering this as a DC bridge. So especially when we deal the Wheatstone bridge, that too in DC, when we apply the DC voltage, there is no question of the frequency, correct? There is no question of the frequency means obviously it is a frequency independent term here. So option D is the straightforward answer, and we all know that especially in Maxwell and screen based. So Maxwell bridge is used to measure the inductance, correct? So in fact I would say inductance of a coil, right? And screen bridge is used to measure the capacitance of a coil. And both of these two are comparison methods, right? In fact, if you see in Maxwell inductance bridge, what we do, we will have a configuration, and at balanced condition, the unknown resistance of the coil can be found by using the three known resistances. Those students who doesn't know anything about the bridges, I sincerely request first to go through the recorded lectures which are available on BYJU'S Exam Prep, or else go through the basic concepts and then come to class here. Clear? Because this class is fully dedicated to only previous year questions. So therefore, let me do justice to the topic here and the task also. Okay. So, and the inductance of the coil you can see that can also be found like this: R2 into R3 into R4, R2 into R3 into C4. Therefore, I could say Maxwell bridge at balanced condition, it doesn't require the support of any frequency here. So it is a natural frequency independent term. And the similar thing, similar theme will be there even in the screen bridge also. So screen bridge is used to measure the capacitance of a, of course, capacitance. So the capacitance can be found like this. This is the formula that we use for the capacitance. Of course, the resistance of the capacitor can be found like this. Now, both of these two I could say frequency independent. Okay, so that means I would be agreeing with the option A and even option C. So A, C, D, 100% I am sure that these three options are correct. These three options are perfectly alright. The only option where you may get doubt is a Wien bridge. Now you must know the fact here, Wien bridge is an oscillator. Of course, it will generate a wave. Suppose if it is generating a wave, because it is a waveform generator, if it generates the wave, the frequency of the wave could be depending on, so in fact I should say frequency depends on, it's a function of the frequency is a function of the elements, like you will have resistance and capacitance, whatnot, R1, R2, C1, C2, depending upon the structure. We will be, sir, there is no frequency relation in the max. Yes, correct. Shubham Pal, you are right. That's why I am saying that option A and option C, option D, all three options are right. You are absolutely right. So the only problem is the Wien bridge. In Wien bridge, when you are finding the frequency of the Wien bridge depends upon the resistor and capacitor or the circuit parameters that are used in the bridge configuration. Therefore, I cannot go with the option B, but A, C, D are correct. Will you agree with me, Shubham Sri Pal? So please let me know, is it okay? This question is really good. I like this question because whenever a multiple select question comes, usually it's a tedious job for the students to pick up the correct answer, because you have to be very careful with your fundamentals, right? So please let me know, Shubham, is it clear to you? A, C, D or the correct answers for this question. Let me quickly go to the next question here. Next question is very simple. Let me read the statement of the question. Of course, this was asked in electrical 2021 paper. The statement of the question is, inductance is measured by dash. So again, this is also a very simple question, because we all know that just before this itself I told you that screen bridge is used for capacitance measurement and Maxwell bridge is used for the inductance measurement or inductance of the coil, specially speaking, and Kelvin bridge is for low resistance. Let me write down this is for low resistance, of course, and Wien bridge is for frequency. Correct. So let me write down this is for frequency measurement, right? So what would be the correct answer here? So obviously the correct answer is option B, right? Very good, Thirumalal. GATE aspirant, excellent. So option B is the correct answer. In fact, it is a simple question. Being my student, you should not take this much of time. I love the students who have given the answer very quickly. Appreciate you guys. So let's move on to the next question. This question is relatively a good question. So when I am making this, in fact, when I am typing this question in the PPT, I understood that this is a relatively good question. The reason is not about the depth of the question. Many students, by looking at this configuration, they leave the question. They leave the question without reading the complete statement. Clear? Right? So, yes, in the Wheatstone bridge circuit shown, R1 is equals to 1.5 kilo ohm, R2, R3, R4 is equal to 1 kilo ohm. Clear? So that means R1 is technically it is equal to 1.5 kilo ohm. Please look at and read the statement of the question clearly. This is 1 kilo ohm and even this is also 1 kilo ohm here and even this is also 1 kilo ohm here. Correct? So this is how the pattern is there. Well, the switch is initially open and the voltage between the points C and D is VCD. So he himself is saying that initially the switch is open and you are able to measure the voltage between C and D. So maybe this is plus and this is minus, and where do we connect the voltmeter? So guys, take pen and paper, be active in the session and solve by yourself. I like the student who answered this question very fast. Upon closing the switch at T is equal to 0, the resistance in the arm AD changes by an amount delta R1. Very good. So that means he is saying that second time when, see, this is AD, second time when the switch is closed, the resistance naturally changes because 30 kilo ohm and 1.5 kilo ohm both comes in parallel, right? Well, what he is asking? He is asking that and the voltage between the C and D changes by delta VCD. Very good. So that means the change in voltage also we need to know or we need to calculate. The sensitivity of the bridge in volts per kilo ohm is defined as delta VCD divided by delta R1. Of course, we are going with the magnitude is dash. Such a fantastic question, right? So 1.6 amp, how you can say 1.6? Because it is actually the ratio between voltage and resistance, right? Oh, okay. Very good, right? So let us see whether that is correct or not, because technically you should not give like that, but let us see what is the situation here. So VCD could be written as the output voltage, that is VCD. So VCD is equals to, how can I write? The source voltage is a 10 volt here, supply voltage is 10 volt. So let me write down source voltage as Vs here. Of course, if you look at the parameters here, so VCB, in fact I should say all put together, just give me 1 second time. So let me write down clearly, because there might be some students who doesn't know these basics. VCD, VC minus VD can be written as VCB minus VDB, right? So therefore I can write down this as VCB minus VDB. This is the fundamental point, right? Fundamental basics here. Shubham Sri has given the answer very fast, damn fast. I like you. So please look at other students, please follow in the session and tell me whether that statement is correct or not given by the Shubham. So VCD is equal to, what is VSB minus VDB? Just apply the voltage division rule here. So VCB can be written as Vs. I am taking Vs common because Vs will be there in both the cases. So 1 kilo ohm divided by 1k plus 1k. So 1 kilo ohm divided by 1 kilo ohm plus 1 kilo ohm. That's very fine, easy to understand, no complexity here. Minus this side it is going to be 1 kilo ohm, nice, 1 kilo ohm divided by, so 1 kilo ohm plus 1.5 kilo ohm at so when the switch is open, right? So that means 1 kilo ohm plus 1.5 kilo ohm. Any answer fatafat here? What is the value of the output voltage here? So this is when switch is open, at switch is open. Switch is open. So please keep this in the mind. When you open the switch, you are having 1.5 kilo ohm here. I require the answer from every one of you. Please participate in the session and tell me the calculation part. Every one of you. First, 1 kilo ohm by 2 kilo ohm. This is going to be 1 by 2 minus this is 1 by 1.5 plus 1. So that is 2.5 here. So anyway, minus doesn't make any difference here. So we don't require to worry about minus. But anyway, we will not get minus also. 10 into, what is the voltage here? Any one of you quickly do the calculation and tell me. So this is 1 divided by 2.5. So minus 0.5 here. Well, so into 10 here. So of course you will be having 10 into minus 0.1. So therefore I could say this is equal to, so in fact minus plus only 0.5 minus 0.4. So 0.1 into 10. So it is equal to 1 volt. How many of you got this one, 1 volt? Please let me know in the comment section. I will be very happy to see the response from your side. This is 1 volt when the switch is open. But is it your final answer? No, right? So when the switch is closed, so let me go one step ahead and do that. When the switch is closed, switch is closed. Suppose if the switch is closed, can you tell me first what will be the change here? So because when the switch is closed, the overall resistance here is the parallel combination of these two resistors. Therefore, I could say the resistance between RAD. So RAD is equal to how much? 1.5K, 1.5 into 30 divided by 1.5 plus 30. So this is going to be 31.5. Of course, you will be having kilo ohm here, right? Still kilo ohm is same. So what is the resistance here? Very good, gate aspirant. Very good, very good. So please let me know what is the value here. Every one of you do fast. 1.5 into 30. So this divided by 31.5 here, of course. So you'll be having 10 point. So it is equal to 1.4285. So let me take it is equal to 1.43 approximately. 1.43 kilo ohm is the resistance that you are having now, right? But have you seen in the previous case, right? So that means suppose in the first case here, what is the value of DC? Sorry, one second. RAD. RAD in the previous case, it is simply like how much? Previously the switch is open, so we have only 1.5 kilo ohm here, correct? So therefore I can say when the switch is open, this is straightforward and 1.5 kilo ohm. And when the switch is closed, then I can say RAD is equal to how much? That is equal to 1.43 kilo ohm. Just now I told you here, right? Any answer from other students? Subham Ashi is the only person who has answered me very fast. Other people, please let me know what is the answer. So VCD could be written as, again, 10 volt I can say into 1 by 2. So I am writing directly now because I pre-assume that you guys know how to solve this output voltage of the Wheatstone bridge, right? Because this is very, very basic. Minus 1 divided by 1 plus, instead of 1.5, now I need to write down 1.43. So simple here, right? So what would be the final value of the voltage, right? VCD 1. Let me call here this as a VCD 1, VCD 1 in the first case, and second case, let me call this as VCD 2 and VCD 2. This is going to be RAD 1 and this is going to be RAD 2, second case. This is going to be second case. Now what is the output voltage? Any answer from any one of you? Guys, you have to improve your speed and do fast. Of course, I should also do that. Very nice. So 1 divided by 1 plus 1.43. How much it will become? Right. So there is some value minus 0.5. Right. So into minus 1. Right. Into 10. So you will be having 0.884. So let me write down 0.884 volt here. So this is VCD2. Correct? This is VCD2. Now tell me what is the change in resistance first. So because you need to get the change in resistance before going to the sensitivity. Delta RCD or RAD, it is equal to the resistance in the second case, that is RAD2, minus the resistance in the first case, RAD1. So how much that will be? 1.43 minus 1.5, right? So 1.43 minus 1.5. How much that is? Please guys, fast. Minus 1.5. So all put together, this is equal to 0.07 minus 0.07. Anyway, minus doesn't require for us because we are going for the magnitude of sensitivity here. This is this. What about delta VCD? That means the change in output voltage. That is equal to VCD2 minus VCD1. That means the voltage in the second case minus voltage in the first case. How much that will come? This will also be negative only because it's less. So what is the voltage? 0.884 minus 1 volt. So this is equal to minus 0.116 volt here. Clear? Minus 0.116 volt. Then tell me what is the sensitivity that is required at the end, because if you look at the statement of the question here, we require the sensitivity here. So therefore let me take this step here, delta VCD divided by delta R1. So anyway we require the magnitude here. Look at this. So how much you are going to have? So that is 0.116 divided by 0.07. 0.116 divided by 0.07. What is the final value here? So any answer from your side? 0.116 divided by 0.07. 7. So all put together it is equal to 1.657. Correct? So let me write down 1.657 and volt per kilo ohm. Obviously, because the resistance change will be in no. This is volt per ohm, right? So I am extremely sorry, just because if you look at clearly, this is not volt per kilo ohm. Why? 0.07 is the change in resistance, that is in the ohms, right? No, 1.43 kilo ohm. Yes. I am sorry. Yes, this is kilo ohm only. No problem. Conveniently we can take this one, 1.65. Very good aspirant, very good gate aspirant. So 1.65 volt per kilo ohm. Correct? So that's the final answer for this question. Truly speaking, is it a difficult question? Tirumalai, please tell me. Tirumalai, Shubham Pal and gate aspirant, please let me know. Is it a difficult question? So already Shubham has answered very fast. Shubham Sri has answered very fast and quickest for this question. Is it difficult question? Technically speaking, this is not a difficult question. It is an easy question. But many students, they don't even read the statement of the question because they don't have the patience to read the entire statement of the question because it looks very big, right? So those students who have the patience, those students who believe in the basics, those students who are committed, those students who can approach the question from the basics, they will only get the result at the end. Clear? So well, let me move on to the next question here. Hope you got really a very good question. This is also a good question. Let me take up this question. In the bridge circuit shown, the voltmeter V showed 0 when the value of the resistors R1 equals to 100, R2 is equals to, so R1 is equal to 100 ohm, R2 is equal to 100 ohm, R3 equal to 100 ohm, R1 by R2 equals to RA by RB. The value of R4 in resistance, R4 is dash. So technically you require to calculate this. But look at, this is a very conventional Kelvin double bridge. Correct? This is a very conventional Kelvin double bridge. There are two approaches here. There are two procedures. Number one is just convert this delta network to the star network. If you convert this delta network to star network, you can find the answer. That is procedure number one. That is basic procedure. But those students who attended my classes or those students who attended any class of measurement, probably definitely Kelvin bridge might be discussed to you and the formula of Kelvin bridge also given to you. Correct? So if you are clever enough, directly you can use the formula if you can, because I feel that more or less every gate aspirant knows this, right? So let me use this formula directly. Otherwise, I told you basic procedure is convert this delta network into star network and then apply the concept of Wheatstone bridge. Easily you will get the answer. Correct? Gate aspirant, what would be the answer here? So he himself told that R1 by R2 is equal to RA by RB. Very happy to see that. R1 by R2 is equal to RA by RB means I could say this total value here inside the bracket, that would be equal to 0. Correct? So if it is equal to 0, obviously the entire term will going to be 0. The entire term here it will be equal to 0. Therefore, what you will going to have now? Now you will be having only like R3 which is equal to R1 into R4 divided by R2 here. Relax. Look at what is R1 and R2 and R4. Every value is given. R1 is 100 ohm, R2 is 110 ohm. Correct? So 100 ohm divided by 110 here into what is the value of R4 here? R4 is going to be, yes, R4 we require to find. R3 is given 90, right? So R3 is given 90. Sorry, R4 we require to find. So let me take R4 as R4 itself, because we don't have that value, and here this value R3 is given like 90 ohm here. Correct? So be careful with the formula here, because even though you know the formula, you must know how to apply the formula also, right? So that is more important. So therefore, what is the value of R4? Any value from your side, gate aspirant, 90 into 110 here divided by 100. Any answer from any one of you? Any answer from any one of you? I expected the answer very fast from Shubham Pal, but disappointed. Hope you might have given the answer very fast. Right, 110 here. So 90 into 110 divided by 100 here. So it is equal to 99. Very good. Nandi has given the answer 99 ohm. See guys, this is a very simple question, provided that if you know this relation. But those students who attended the classes, who have gone with the Kelvin double bridge, they don't forget this concept as well as the formula. If you don't remember the formula, even then I have told you the basic approach. Just convert this delta network into star connection and then apply the basics of Wheatstone bridge, you will get the answer so quickly. Clear? So let's go to the next question. See, there are so many questions asked from the bridges. So AC bridge as well as the DC bridge, especially these bridge concepts are very important as far as the GATE exam is considered. That's why I always say, especially for instrumentation and electrical student, even if you go through only the bridge concepts, there is a chance to get 2 marks in the entire GATE examination. Clear? That much confident I am. So let's go to the next question. 2018. So 2018, the inductance of the coil is measured using the bridge shown in the figure. So very good. Dissipation factor, deflection is 0. Balance means deflection is 0, is obtained with C1 is equal to 1 nanofarad, R1 is equal to 2.2 mega ohm, R2 is equal to 22.2 kilo ohm, R4 value is also given. The value of Lx in millihenry is dash. So you require to calculate only the value of Lx. So let me take here, this is Lx here, in fact this is Ls. Always whenever this is given to you, the best choice is try to take this as a impedance 1, Z1. Clear? So if I take this as a impedance 1, can you please tell me what is impedance 1 here? Z1. Simple here, Z1 is nothing but, so look at that, capacitor and resistor both are connected in parallel. So how do we write this one? So this is going to be R1 into 1 by S into C1 divided by R1 plus 1 by S into C1. This is a parallel combination of resistor R1 and capacitor C1 here, correct? So moving ahead, what could I say here? So Z1 now can be written as equal to R1 divided by 1 plus S into R1 into C1. So please keep these things very clearly because the procedure is very important rather than the solution or rather than the final answer. Okay. So Z2, impedance 2, and it is a very simple resistance here. So this is a Z2. I would be saying that this is a simple resistance. And here we have Z4 here, I should say. And of course, this is all together, this is Z3 here, right? Now, Z2 is equals to R2 here, no doubt. And I would be saying that Z3 equal to what? Z3 we need to calculate, but Z4 is known to us, right? So let me take all the values here. Z3, first let us see what is Z3 here. Z3 is, it's a series combination of resistance and inductance, right? So therefore I can write down this as R3 plus J omega L into X or XL, right? So let me write down for time being, so S into L here, right? So otherwise you can write down if you are interested like J omega also, no problem, nobody will say anything to you, okay? Right, so S into Lx. Now moving ahead, what is the Z4 value here? So move ahead and Z4, any one of you, Z4 is how much? Z4 is simply equal to R4. Now this many impedances are there. What is the balanced condition here? So if you go with the balanced condition, especially in AC bridges, what must be taken here? So we know that balanced condition can be obtained by multiplying the cross impedances like this, correct? So that means I would be saying easily that Z1 into Z3, that must be equal to Z2 into Z4. Z1 into Z3 is equal to Z2 into Z4. Therefore, what should I say? Z1. So as I said, so let me go ahead. Z1 into Z3 is equals to Z2 into Z4. Z2 into Z4. Now relax. What is Z1 here? Z1 is R1 divided by 1 plus J omega into R1 C1, that is Z1 into, what is Z3 here? Z3 is simply like, you know, R3 plus J omega into Lx. So please keep these things in mind, okay? Because as I said, especially in bridges, more than your final answer, the procedure what we are adopting, that is more important, okay? So Z2 into Z4, what is Z2 into Z4? It's a simple resistance here. So therefore I can say R2 into R4. This is very simple. Now moving ahead, I can say R1 into R3 plus J omega into Lx here, that will be equal to R2 into R4 1 plus J into omega. Of course this is going to be R1 into C1 here, correct? So move ahead. So R1 into R3 I would be saying plus J into omega into R1 into Lx here, that is equals to R2 into R4 once again plus J into omega R1, R2 and R4 into C1. Wow, excellent. So it took some time, but this is required. This is required because even every one of you must solve. It is not possible for every student to remember all the formulas. In the bridges, AC bridges, we have several bridges, starts from the Maxwell inductance, Maxwell capacitance, and then Anderson bridge, Owen's bridge. A lot of bridges are there. Obviously, you cannot remember any formula, right? So therefore, we need to go with the basic idea. In fact, we need to go with the fundamentals, right? Adarsh, good evening, Adarsh. So please go ahead. So what would be the Lx value now? Now look at this one. So compare the imaginary part both sides here. When you compare both sides the imaginary part, I could say j omega into r1 into Lx is equal to j omega into r1 r2. Of course, c1 into r4 here. Correct? So what would be cancelled here first of all? So look at the statement clearly. J omega r1 will be out here. So Lx can be written as equals to r2 into r4 into c1 values. So what is r2 and r4? First of all, look at r2 and r4. R2 is 22 kilo ohm, right? So 22 kilo ohm. So I am extremely sorry guys, this is 22 kilo ohm. Here it was mentioned as kilo ohm, the number is missing here. So time being, let me take some kilo ohm here, like 1 kilo ohm, okay? But you please go through that, what is exact number. So don't worry, because the procedure is important as I said. So 1 kilo ohm if I take there, R2 into R4. So what should I say? 22.2 kilo ohm. So into 10 to the power of 3, of course, R4 I have selected as 1 kilo ohm. So 1 into 10 to the power of 3 here. What about the capacitor here? So capacitor C1 is 1 nanofarad. So well, 1 nanofarad means 1 into 10 to the power of minus 9. Can you please let me know what is the final answer here? This is such a simple thing here, right? So you will be having 22.5, sorry, 22.2. I repeat, 22.2 millihenry. Very good, Nandi. So it will be millihenry. So you don't require so much of hectic calculation, but this takes at least 1 to 2 minutes, at least 2 to 3 minutes maybe sometime, right? So in the examination, but you will get 100% marks, correct? If you don't commit any calculation mistake, the probability of scoring this question is 100%. And these kind of questions you should not miss at all in your final examination. Clear? Right? This can be done by using the quality factor. Try kar do. Adarsh, you try this one. Just use your quality factor formula and look at that whether you can do that. If you are getting the answer, so happy, right? So please, whenever you get some good ideas, so please try to implement first and see. Then you will naturally understand whether that can be done or not, or what are the improvements you can do. That is called self-learning. Self-learning is the best learning. So IN 2020. Now I will use the quality factor here. So please see, Adarsh, I respect your commitment, I respect your idea. So please see here. I will do that by using the quality factor now. So in the Maxwell-Wien bridge shown, the detector D reads 0 when C1 is equal to 100 nanofarad and R1 is equal to 100 kilo ohm. What would be the quality factor of the coil? Clear? Very good. So they are asking what would be the quality factor. There are two ways, because if you know the quality factor of this, directly we can say what is the quality factor of this, right? So that is possible. Directly we can say, because this is a series and this is a parallel combination, right? So the quality factor of this Lx, so I can say quality factor of the inductive coil could be written as omega, so one second, omega into Lx divided by Rx. This is so easy to understand. Correct? Omega Ls by Rs. As Adarsh is asking, we can compare, because at balanced condition, the product of this into this must be equal to product of R2 and R4. Correct? So if you compare this, this is a parallel combination, right? So if it is a parallel combination, for that, how do we write the quality factor? So for that, we can write down the quality factor as it is a parallel combination, straight away I am writing this as a omega into R1 C1. This is not a series combination, it's a parallel combination. If it is a parallel combination, the quality factor will be equals to omega into R1 into C1. Clear? This is straightforward answer. Directly we can solve this. So therefore quality factor now for the coil, inductive coil, can be written in terms of the resistance and capacitance here. Quality factor. What is the idea? Yes. What is the quality factor here? Simple, 10 power 3 into 10 power 5. So that is going to be 10 power 8 into 10 power minus 7. So it is equal to 10, right? How many of you got this way? This is an easy way to solve the question, isn't it? This is really damn easy to, yeah, Adarsh, it is recovered. Now please look at that statement of the question. So the quality factor is going to be 10. Otherwise, this is the procedure number 1. You can solve this by using this way. This is the easiest procedure I could say. And the only thing you need to understand, when the resistor and inductor both are connected in series, its quality factor can be written as omega Lx by Rx. But when you are comparing the quality factor with this, as the quality factor of the parallel combination of resistor and capacitor is equal to omega R1 C1, we need to take omega R1 C1 and equate that, then you will get the answer, right? So those students who don't want to use this directly, then you can again take this as a Z1 here. So take this as a Z1 and this is going to be Z2 here, and this might be Z4 here, and this might be Z3 here. So let me write down directly here, because the balanced condition is very simple here. Z1 Z3 is equal to Z2 into Z4. So easy, isn't it? So what should I say? So Z1 is what? The procedure number 2 I am doing here. Procedure 2, second procedure in fact. Second procedure could be like this also, right? Resistor and capacitor both are connected in parallel. So R1 divided by 1 plus j omega into R1 C1. Clear? That is Z1 into, what is the Z3 value? Z3 value I can say this equals to Rx. So let me write down Rx plus j omega into Lx, right? And that must be equal to right side R2 into R4 here, correct? R2 into R4. So easy here. Now, is it the same thing like what we have done so far? So this and the next question is same. Whatever we have done all the way here, that can be straight away used here. So Lx can be written as R2 R4 C1. So therefore even here also Lx can be written as R2 R4 and C1. This is so easy. And what about the other thing here, that is Rx here? So look at that, what is Rx here? So look at Rx in the previous question. In the previous question, if you compare R1 here, because Rx and R3, yes, R3 is equal to R2 by R1 divided by R1. R2 R4 divided by R1. Yes. Now you can take this value of Lx and Rx and substitute this value of Lx and Rx straight away in this formula here. Then you will be getting quality factor is equal to omega into R1 into C1. Is the procedure 2 is clear or not? After comparing these two, whatever the values you are getting for Lx and Rx, take these values and resubstitute here. Then directly you will get like omega R1 C1. Both the procedures are good. Any procedure, whatever you want, you are convenient, you can use that. There is no limitation that you must use only this procedure. Hope you really enjoyed this question. I have given two solutions, in fact 2 methods, right? Now let's go to the next question here. Next question was asked in 2019 paper, Instrumentation 2019. Oh, this is a little bit lengthy question. Anyway, we need to work out this. Let's go with this. The parallel resistance capacitance bridge shown below has a standard capacitance C1 is equal to 0.1 microfarad and the resistance value of R3 is equal to, I think this is R1. So this is R1. So small change, because C1 and R1 are associated here. R1 is given and C1 is given. Good. So the bridge is balanced at a supply frequency of omega. F is given like 100 Hz. Please try to note that this is F. It is not omega. It is F. It is not omega. Nandi, Adarsh, Gate Aspirant, Shubham, Tirumalai, please put your pen down on the paper, calculate fast and let me know the answer. And then it was also given that R1 and R3 value and R4 also given here. Okay, so I think yes, and a resistance value of R1 10 kilo ohm. The bridge is balanced at a supply. Sorry, I think there is a data is conceptually mistake here. So, well, one second. The value of the dissipation factor D 1 by omega Rp Cp of the parallel combination of Cp and Rp is dash. So I think this might not be required here. Okay. So this R1 is given here, R1 and C1. Please note down that this is not required. It may be printing mistake here. Please do consider the value of C1 is given and the value of R1 is given here. So I don't want to confuse you. Clear? So now R1 value is there, R2, R3 value is there, R4 value is there, and the most important thing is Rp and Cp we need to calculate. Well, I think there is no issue at all. see, R3 value is given 2 times, that's all. So even here it was mentioned that R3 is equal to 10 kilo ohm, and here also it was mentioned like 10 kilo ohm. It's okay, right? So what is the way you need to proceed now? First, let us consider the impedance as Z1 here, and let us consider this impedance as Z2 here, for example, and this may be Z3 here, and this may be Z4. Now can you tell me at balanced condition what will happen? Z1 into Z4, technically that must be equal to Z2 into Z3 here. So Z2 into Z3, Z1 into Z4 is equal to Z2 into Z3. Now relax, try to go with the basics here again. What is Z1? Z1 could be written as R1 divided by 1 plus j omega into R1 into C1, R1 into C1 into Z4. What is Z4? That is nothing but R4 here. That is equals to Z2 into Z3. Z2 can be written as RP here divided by 1 plus j omega into RP CP here, RP into CP, and Z3 is how much? Z3 is actually nothing but R3 here. Clear? Now moving ahead, what should I say? So this will be equal to R1 R4 divided by R1 R4 divided by 1 plus j omega R1 C1, 1 plus j omega R1 C1, correct? J omega R1 C1, and that must be right side, it must be equal to R3 into RP, R3 into RP, so divided by R3 into RP divided by 1 plus j omega RP CP, 1 plus j omega RP CP here. Simple. Now multiply both sides, then what you will going to get here? R1 R4 into 1 plus j omega into RP CP. There is no option here. We need to move with this, and if you get any good idea or any crazy idea, please share in the comment section. I'm ready to take the suggestions from your side, no problem. 1 plus j omega into R1 C1. So let's continue still till the end. So if you still continue, it will become like R1 R4 plus j into omega into R1 R4 into RP into CP here. Clear? So that can be equal to what? R3 into RP, of course, plus j omega into R1 C1 R3 RP here. So please do calculate everything properly till the end, because this simple calculation, many times if you miss one alphabet, then you will end up with the wrong answer. So please be careful with this. So from here, if we compare the real part, then I can straight away say from this R1 R4 equal to R3 into RP. Therefore, I can say clearly that RP is equals to R1 R4 divided by R3 here. Simple. It's completed. Now go ahead. Go ahead with this one, that is j omega R1 R4 RP and CP here, RP and CP, that is equals to R1 R4 RP and CP here, RP CP. Right hand side you will be having like j omega R1 C1 R3 into RP here. So relax and try to work out clearly here, because there is a huge probability that you may commit the mistake here. Clear? So please see carefully. J omega R1 and j omega R1 out here, and RP is out here, RP is out here, correct? Very easy. And then what is C1 here? So C1 could be written as equals to R4 into CP divided by R3 here. Simple. So C1 is this. In fact, CP we require. I'm extremely sorry guys. What we require is CP, I think so, right? CP we require. So just go with the CP calculation. CP is equals to, what should I say? C1 into R3, C1 into R3 divided by R4, C1 into R3 divided by R4. Now we have this set of data here. Use this data wisely, because what is our final goal? Our final goal is to calculate dissipation factor D. What is dissipation factor? Please go ahead. Go to the question. He himself has clearly mentioned that dissipation factor is equal to 1 divided by omega into RP into CP. So use your common sense and tell me what will happen here. So dissipation factor is usually inversely proportional to the quality factor. Clear? So 1 divided by omega RP CP. So 1 divided by omega will be there as usual, but RP, when you write RP here, R1 R4 divided by R3, R1 R4 divided by R3 here. What about CP here? R1 R4 divided by R3, and here Cp can be written as C1 R3 by R4. C1 R3 divided by R4. Correct. So therefore, what should I say here? So from here, the easy way to rewrite this is, here we can say R3 will be out, R4 will be out. So therefore, dissipation factor is equal to 1 divided by omega into R1 into C1. Simple, right? So now we need to put all the values, because you do have all the values here, right? So just let me go with this slide here. Now we understood that dissipation factor is equal to 1 divided by omega into R1 into C1. That's what we understood. These both are same. This both are same. But how do we know that? Because we have solved all the way this question. That's why we came to know that, right? So therefore, use everything, RP and CP value. Yes, R1 and C1. So 1 divided by omega is equal to 2 pi f, 2 into 3.14 into 100, frequency is 100. So 2 pi f means 10 square. And R1 C1. What is R1 and what is C1? R1 is 375 kilo ohm. So 375 kilo ohm, 10 power 3 and 10 power minus 7. So it is 10 power minus 4 here, correct? So 10 power minus 4. Just one step before the answer here. 2 into 3.14. So let me write down 2 into 3.14 into 375. Of course, 10 power minus 4, 10 power minus 2 and 10 power 2 it will become. So it is 100 here. So what is the final answer? Any answer from your side? Adarsh has given the answer. Adarsh is in line with me. Thank you, Adarsh. So 2 into 3.14 into 375. See, these kind of questions take some time, but you must not lose your confidence, right? So obviously difficult questions will going to give brief idea about the subject also, right? So 0.042, that is the final answer. Adarsh, very good Adarsh. 0.042. What about Nandi? Nandi, have you got the answer? And if you find any easy answer, easy way or the shortcut or anything, if you know, try to check whether that gets worked out here or not. Okay. So 0.042 is the correct answer. Let's quickly move on to the next question here. Well, there are a lot of questions which are asked only in the bridges. So that's why let me take some time to explain these things clearly. So IN 2022, the question is this, right? So let me go with this. The bridge shown is balanced when R1, R2, of course, all the values are given. The 2 kHz sine wave generator supplies the voltage of 10 volt peak to peak. This is a sine wave generator, right? And its frequency is 2 kHz. So F is equal to 2 into 10 to the power of 3 Hz here, right? Its peak to peak voltage also given. Okay. The value of L3 is dash. What would be the value of L3? That is the question here, right? I think the similar, because it is also a deflection. It is also a deflection. Similar kind of question we have already solved, right? In fact, this is Maxwell inductance and capacitance bridge. Look at this. Here also we have solved the same question, if you remember. And what would be the value of Lx there? Value of Lx is equal to R2 R4 into C1. R2 R4 into C1. R2 R4 into C1. That is what we have seen. That is the value of Lx. R2 R4 into C1. So in this case, what will going to happen now? In this case, what will going to happen? R1 and R4. These are the resistors that are there. Product of these two into C2. So therefore, let me write down directly here, because we have already solved this several times here. Sir, I am having some problem in wattmeter and energy meter. Where to practice? Adarsh, I have taken a special classes on wattmeter as well as energy meter. No need to do anything anywhere else. In the YouTube itself, you can go through my lectures. I have comprehensively explained those things. Those two concepts very clearly with the questions, numerous questions I have explained in the YouTube. Please go through that. You will be able to do every question and any question. So here, this must be multiplied like this. R1, R4, of course, this could be now C2 according to this figure, because R1, R4 and their R1, R4 both are different, but the style of the question is same, correct? So therefore, L3 I am writing. This is called Maxwell inductance and capacitance bridge. Please note down that. What is the R1 value here? R1 is 100. What is the R4 value? R4 value is 50. Very nice. Into C2 value is how much? 2.9 microfarad. 2.9 into 10 to the power of minus 6 here. Correct? So therefore, L3 could be written as here. So let me write down clearly. Yes. 100 into 50 into 2.9. So it will be 14,500. 14,500 into 10 to the power minus 6 here. So I would be saying 14,500 into 10 to the power of minus 6. So this will be, I could say easily, that as 0.0145 Henry. Clear? So 0.0145 Henry. So 1.45 into 10 to the power of minus, yes, 10 power minus Henry. In fact, if the question is about millihenry, so I need to be very conscious about this one. It's about millihenry, right? So 14.5 millihenry. Clear? So please be careful with this because the question is about millihenry. So answer for this question is 14.5. Good question, right? Nandi has given the answer once again very quickly. Very good. 14.5 millihenry is the answer for this question. Let's go to the next question. Next question. So it is the instrumentation question only, but I would say it is a core instrumentation. This is a core instrumentation question. So let's go with that, right? Because this question is related to sensor. By mistakenly it was placed, I guess, here. So this question is related to sensors, right? So it is a core instrumentation part, and anyway we will going to discuss by the time when we come to core instrumentation. Clear? Core instrumentation. So by mistakenly it was placed. So let's get into that one. Next question. Of course, those students who want to get the regular updates and quick updates, please stay connected to BYJU'S Exam Prep channel. Don't miss this. Okay. So as I said, we will be starting from tomorrow onwards the marathon sessions, right? At 10 p.m. today, we will be giving the route map to you. We are coming onto live. We will be giving the route map to you, and tomorrow onwards we are going to start the marathon sessions. Okay. Very good. So let's go to the next topic, that is CRO and Q meter as well as the DVMs. Even these three topics put together, every time we are getting at least one question, either of 1 mark to 2 marks. So though these three topics are different, obviously I do agree that these three topics are different, but more or less the questions are coming as a combination. So we should respect that, right? So let's get into the first question on the CRO, which was asked in 2018 paper here. So a voltage of 6 cos 100 pi t volt is fed as a Y input to a CRO. That means it is a test signal, right? It's a test signal because Y channel we are going to give only test signal or the signal that is coming out of the circuit, and the X coordinate or X input will be always given with the sawtooth waveform, time based waveform. The waveform seen on the screen of the CRO is shown in the figure. The Y and X axis are having a setting of dash. This is a simple question. Any answer from your side? Namdi or Adarsh, any one of you. Any one of you. I appreciate the student who can give the correct answer very fast here. So look at that. So the voltage waveform is what? First of all, V of t is equal to 6 into cos 100 pi into t. Correct? 100 pi into t. Now if you look at, if I start with this as a 0 here, right? This is a 0. 1, 2, 3. In fact, 3 boxes it occupied to reach the peak value. That means I am very sure that this must be 6, right? No option here. It must be 6 because the peak value is 6 here. Correct? So therefore this is 6 volt, means obviously I should take this as a 4 volt only, and this might be 2 volt here. Then this is going to be 0 volt here. Correct? So therefore what is this means? Every box contributes 2 volt here. So 2 volt per division is the correct answer. So that means 2 volt per division on Y axis. On Y axis, sensitivity is 2 volt per division. This is a very simple question, right? So and then we require to know about the time period. So very nice. Adarsh has given the answer so fast. So this is omega. So let us say omega is equal to 100 pi, right? But we know omega means it is 2 pi f here. So let us say 2 pi f is equal to 100 pi here, right? So pi will going to get cancelled. F is equal to 50 Hz. First of all, if f is equal to 50 Hz, if the frequency is equal to 50 Hz, what would be the time period? Time period is equal to 1 by 50 here. 1 by 50, I could say it is equal to 2 millisecond if I am not wrong, right? So 1 by 50, yes, 1 by 50 is 0.02, 20 milliseconds. This is going to be 20 milliseconds. That means the waveform should occupy 20 milliseconds of time. So look at that. One single waveform is given. One single waveform is given. This is the first box, second, third, 4, 5, 6, 7, 8, 9, 10. So 10 boxes, it is covering one wave. So 10 boxes, it is covering one wave means 20 milliseconds. So 10 divisions on x-axis are contributing 20 milliseconds. So 20 milliseconds here. Therefore, what should I say? 1 division on x-axis, it would be equal to how much? 1 division is equal to 2 millisecond, right? 2 millisecond per division. In fact, 1 division is equal to 2 millisecond means 2 milliseconds per division. What would be the correct answer? Option D is the correct answer. So Adarsh, look at that. Option D or option C is the correct. Option D is the correct answer. 1 division has to contribute 2 milliseconds. Then only 10 divisions will going to contribute 20 milliseconds. So this is x-axis setting. This is x-axis setting. Adarsh, is this clear to you? X-axis setting is 2 milliseconds per division. Y-axis setting is going to be 2 volt per division. Option D is the correct answer. This is a simple question. Let me go to the next question. In fact, next question is very simple. Let me do fast here. So the network shown below has a resonant frequency of 150 kHz. Okay, so let me write down fatafat first of all. Resonant frequency, let me write down FR, which is equal to 150 kHz. 150 into 10 to the power of 3 Hz. No doubt about that one. This is simple. And a bandwidth of 600 Hz. So let me write down the bandwidth here, which is equal to 600 Hz. Right? And the quality factor of the network is what? Quality factor, I hope you guys know about this one. No problem, Adarsh, it happens. That's why you are attending these sessions. So please reduce your mistakes and increase your accuracy as well as speed also. Okay. So therefore the quality factor can be written as, there is a straight formula. Hope those students who attended my measurements classes as well as circuit theory classes, they know very well about this. Quality factor is equal to resonant frequency divided by bandwidth. It's the straight formula. What is the resonant frequency here? 150 into 10 to the power of 3 here, and divided by the bandwidth is equal to 600 here. So what is the final answer? 150 divided by 600 into 10 to the power of 3. Any answer from your side fast, guys? So 150 divided by 600, that is 1 by 4, 0.25 into 1000, right? So therefore it is 250. So quality factor is equal to 250 here. Simple question. Quality factor is 250. Very good, very good. Anandiya Bose, very good. This is a simple question, I would say. Sometimes we do have a simple question in the gate also, but those students who don't know this relation, then it's a nightmare for them, right? So they cannot solve this question so easily. So this relation should be known to you. Otherwise, you need to know what is the procedure to get this relation. Then only you can solve this, right? Moving ahead to the next question. So 2018 question, a high quality factor. Wow, itself is given like a high quality high quality coil having a distributed, wow, self capacitance is tested with the quality meter, that is Q meter. First resonance is occurred at omega 1 is equal to 10 power 6 radian per second, is obtained with a capacitance of 990. Okay, the second resonant frequency is obtained at omega 2 is equal to this, and 240 picofarad is the value. Very good. So the value of the inductance is going to be how much? Value of the inductance is going to be how much? So first of all, you must know, I am not drawing the complete picture of the Q meter, but in Q meter there are two ports. In one port we are going to have a coil which has the inductance and the distributed capacitance, and we will be having another port where we are going to have a adjustable capacitance. Correct? Let me take the adjustable capacitance also. So adjustable capacitance is here. In fact, this is a variable capacitance, right? And these two are excited ideally by a practical, so ideal voltage source Vs, and resonance will be obtained. So for that, what we do is, first we will change the test capacitance C to C1. So that means we will get at omega is equal to omega 1, there is a chance to get the resonance. At that time C will be equal to C1. That means first time we will change the capacitance to C1 and we will get a resonance. So note down the resonant frequency. That I am calling as omega 1. So how do we write the omega here now? Omega is equal to 1 divided by under root of L into C 1 plus CD. Why? Because the net capacitance here will be equal to CD plus C1. Correct or not? CD and C1 both will going to contribute in the resonance now. Right? This is one aspect. And now in the second case, what we do is, we will still change the capacitance to another value called C2, such that we will again get the resonance at another frequency. So that means at omega is equal to omega 2 now, right? Omega is equal to omega 2, and probably this omega 2 we will try to ensure that it is more than 2 times of omega 1. Here also you see omega 2 is equal to 2 into 10 to the power of 6 radian per second, and omega 1 is equal to 10 to the power of 6 radian per second. This is 1 into 10 to the power of 6 radian per second. Clear? So therefore omega 2, how can I write this one? Omega 2 is equals to, what should I write? So here it will be equal to 1 divided by under root of L into C2 plus CD. C2 plus CD. This is omega 2, right? So now omega 2, once again, omega 2, once again, I'm sorry, omega 2. Omega 2 is equal to 2 times of omega 1. So omega 2 is 1 divided by under root of L into C1, C2 plus CD, second time capacitance. That's this side it will be 2 divided by under root of L into C1 plus CD here. Clear? C1 plus CD. Relax and try to calculate the distributed capacitance first, because if you get distributed capacitance, then we can actually get the value of, you know, whatever you want, everything we can calculate, right? So just look at that, square on both sides, what you will going to get. So the same relation we can cancel. In fact, let me erase this one. So this can be removed here, this can be removed, this can be removed here, and this side now it will become 4, because we need to square this, right? So it will become 4 here. So therefore C1 plus CD, obviously it will be equal to C1 plus CD and 4C2 plus 4 times of CD. Simple. So 3 times of CD now, that is equal to C1 minus 4 times of C2. 4 CD minus CD, that is 3 CD, C1 minus 4 CD, right? So CD is equal to C1 minus 4 C2 divided by 3 here. Correct? So look at that. What would be the answer? Any one of you from your side. What is C1 here? So they have given everything here. C1 is the capacitance where we got the first time resonant frequency, that is 990 picofarad. What about C2? Second time we got at 240 picofarad. So 240 picofarad. C1 and C2 both are known to us. So therefore I can go ahead. C1 is 990 picofarad minus 4 into 240 here. So let me write down 240. Of course, this will be still picofarad only, divided by 3. Any answer from your side, guys? What is the distributed capacitance? I'm waiting for your answer. So I need to know how many of you are in line with me, how many of you are aligned to me. 990 minus 4 into 240. Let me write down 30. 30 by 3, it is going to be 10 picofarad, right? So I could write down this as 10 picofarad. 10 picofarad is the capacitance, distributed capacitance. But still, is it your question? No. Look at the statement of the question once again. So we require to calculate the inductance value. So we require to calculate the inductance. How do we calculate this? Take any frequency. Take this frequency omega 1. So let's go with the omega 1 now. Omega 1 already we know that is equal to 1 divided by under root of L into C1 plus CD. This already we know, right? So what is omega 1? 10 power 6 here equals to 1 divided by under root of L, we don't know L value, into C1 plus CD. C1 plus CD. What is C1? C1, go back here, C1 is equal to 990 and CD is equal to 10. So 1000 picofarad. 1000 picofarad means 10 power 3 into 10 power minus 12. So 10 power minus 9 here. Correct? So be accurate on these things. So if you square on both sides, it will become 10 power 12 equals to 1 divided by L into 10 power minus 9 here. So therefore L equals to any one of you, what it will become? 1 divided by 10 power 12 into 10 power minus 9. So it will be 10 power 3. So 10 power minus 3 is the final answer. 10 power minus 3. So 10 power minus 3, 1 into 10 to the power of minus 3 Henry. So therefore final answer for inductance is simply like 1 millihenry. So such a good question this is. Pavan Nani, hi sir, hi Pavan, how are you? So good to see you, I guess. Right, 1 millihenry is the final answer. So again, this question is not a difficult question, but you require the basics should be very, very perfect. Correct? So moving ahead to the next question, electrical 2022. So let me go with this question. This is also a good question, I feel. An inductor having a quality factor of 60 is connected in series with a capacitor of having a quality factor 240. Then the overall quality factor of the circuit is dash. Very good. So let's go with this quality factor measurement here. So the first, there is an inductor. So there is an inductor. So it has a value of quality factor 60 means it's a practical coil. So let us say R1 and L1. What is the quality factor of this one? Q1, let us say, that is equal to omega naught into L1 divided by R1. So this is given as 60. This is given as 60. And they are also saying that this is first one. Second one, there is a resistor and capacitor combination here. So they are saying that this particular R and C, maybe this could be like resistor R2 and this is C2. In this case, the quality factor could be written as 1 divided by omega naught into R2 into C2. And this value is given like 60 here and this value is given like 240. Clear? I hope you understood this. And especially at resonance, one important point you must know, at resonance if you know omega naught into L equal to 1 divided by omega naught into C. Clear? 1 divided by omega naught into C. This is a very, very valid point. I too agree with this. So therefore, wherever I have omega naught into C, there I can replace that with the omega naught into L, right? So therefore, I could say the same 240 here. Anyway, let me go with the quality factor of the whole coil, right? So Kunal Mish, sir, I don't know about the measurement, but I solve questions because of you, sir. You explains concept very clearly. Right. Thank you very much. Thank you very much, Kunal Mosam. It's a wonderful statement and lovely appreciation. I am really overwhelmed to see the response from you. And this is what exactly we require. We at BYJU'S Exam Prep, as a team of BYJU'S faculty, we always love to teach with a great passion, right? Our ultimate aim is maximum number of students should get benefit out of this, okay? So I'm very happy to see these messages, and please be on the track, prepared till the end without, any hassle things. Definitely you all can get the success here. So let's go for the complete setup here now. Complete setup means now here we are having the resistor and inductor and again resistor and capacitor here, correct? So let me write down R1 and L1 here and R2 and C2 here, right? So please relax here. This is a total setup. For total setup, if I ask what is the quality factor, how do we write this one? So quality factor for this total setup, I can say resistor is R1, R2 and inductance is L1. So therefore omega naught into L1 divided by R1 plus R2. So simple to understand this. You don't require, yes, hi Hemant Krishna, how are you? Long back I have seen and now I am seeing you once again, right? So see here, 1 divided by, this can be, because here the coil inductance is L1, R1 and R2 is the total resistance. So quality factor can be written as omega naught into L1 divided by R1, R2. Of course, we don't require capacitor to be used here. If you want to use, you can use only the capacitor. Hemant Kushar, big fan of control system and network analysis. Thank you very much, Hemant. And guys, really, I am very happy to see you all back to the chat box here. And I am very happy to see lovely messages from your side. But I wish all the best to each one of you. And I am sincerely thanking every one of you for your great patience, right? You all have done wonderful, hard work so far. Please continue the same thing till the end. Tomorrow we are coming with the marathon session. Don't miss the marathon sessions, because morning to evening some sessions will be continuously going on, and the revision will be provided along with the great practice also. So be with us, right? So here R1 divided by omega naught into L1 first thing, and R2 divided by omega naught omega naught into again L1 here, correct? So simple to understand. This is the overall quality factor. So still if I go ahead, what is the overall quality factor? So Q is equal to 1 divided by, what is this? R1 by omega naught into L1. That is 1 divided by Q1. So see here, this is Q1. 1 divided by Q1. Exactly, it's the reverse of this. R2 divided by omega naught into L1. So what should I say? Omega naught into L1 could be written as omega naught into C2 here at resonance, correct? So therefore, I can say wherever omega naught into L1 is there I can remove this and conveniently rewrite this as 1 by omega naught into C2. Therefore, it will going to be equal to R2, omega R2 and C2 here. But what is this? This is actually nothing but what? This is the reverse of Q2 here. But this is the reverse of Q2. So therefore, what should I say? Plus 1 divided by Q2. That is exactly what you will be getting. And if you go ahead, then it is a product of quality factors Q1 and Q2 and divided by the sum of the quality factors Q1 plus Q2. This is such a wonderful question, isn't it? How many of you really enjoyed this question? Guys, please mention in the comment section. Truly speaking, I enjoyed a question. I enjoyed this question because the first time I am solving, but still we have done it very accurately here. So let's see what is the final answer. Already Shubham has given the answer. Shubham Sri Paul has given the answer. Let me check the answer here. So 60 into 240 here divided by 60 plus 240. So that is 300. So simple question. This is in fact simple calculation of 48. 48 is the answer. Thank you very much and great. Very good Shubham Sri. Please maintain the same rapport till the end. 48 is the answer. Let's go to the next question. So IN 2020. A 200 millivolt full scale dual slope analog to digital converter. So it is a ADC, dual slope ADC. That's why it is called as a DS ADC. Has a reference voltage of 100 millivolt. First of all, let me write down the given data clearly. Then we will get some clarity. The reference voltage is equal to 100 millivolt, right? And then the first integration time is set to 100 millisecond. T1 is equal to 100 millisecond, and the DC, the dual slope ADC, is operated in the continuous conversion mode. The conversion time of the, in fact the total conversion time, it means that we require total conversion time of the dual slope ADC for an input voltage of 123.4. So let me say the input voltage here is equals to 123.4 millivolt, right? So is rounded to 1 decimal. Okay, so I think we require to know what is the total conversion time. But probably those students who attended my recorded lectures or else who have gone through the dual slope integrator, you might be knowing that in dual slope integration what we do is first we will integrate the input voltage and then deintegrate the reference voltage so that we come back to the same position where we started. So the slope must be same. So during the integration time, we integrate the input voltage for a time of T1 and this must be equal to reference voltage into deintegration time, that is T2. Clear? So this is slope 1 and this is slope 2. In dual slope we equate these two. Clear? So from this, what is the deintegration time T2? T2 is equal to Vi divided by V reference, of course, into T1. So let me go ahead again. So what is Vi? Vi is equals to 123.4 millivolt, right, divided by, what is V reference here? Once again, V reference is how much? 123.4 millivolt divided by V reference. V reference is 100 millivolt into T1 is how much? T1 is 100 milliseconds. 100 milliseconds here. So this will get cancelled here and you will be having only 123.4 milliseconds, right? So let me write down clearly. This is going to be milliseconds actually. So 123.4 milliseconds here. So that is T2. Then what is the final answer here? So the final answer is so simple here, because after getting the integration and deintegration time, what would be the yeah, thank you very much, backbone of BYJU'S of electrical. Thank you very much. Thank you very much for lovely compliments today, Pawan. Thank you very much, Pawan Nani. So T1 plus T2 is going to be what? Total conversion time TC. TC represents the total conversion time. It's not the clock time, it's the total conversion time. Total conversion time equals to T1 plus T2. What should I say? T1 plus T2. So T1 is 100 milliseconds, T2 is equal to 123.4 milliseconds, all the way 100 milliseconds plus 123.4 milliseconds. So all put together it will be equal to 223.4 milliseconds. This is the final answer for this question and that is your total conversion time. 223.4 millisecond is the final answer. In fact, it was asked in millisecond only. Clear? So thank you very much, Pawan, but I would like to say each and every faculty in BYJU'S team, all put together for each and every subject, everyone is very experienced, and in fact each faculty has the experience of teaching nearly, every faculty taught more than 300 batches, right? So as a team, BYJU'S is really doing wonderful for the GATE. It is all you need to come forward. You should explain what are your requirements to us. Definitely we will be always one step ahead of all other people to serve the students in the better possible way. So please come to us and explain your requirements, and we are always damn ready to help you. Okay. So well, that is about 222.34 millisecond is the final answer for this question. Moving ahead, next one, IN 2020. So a 6.5 digit timer counter is set in the time period mode. Very good. That means whatever the reading it is giving now, that should be time period, because it is in the time period mode of operating, and the range is set into the nanoseconds. Good. Range is set into the nanoseconds. Moving ahead, for an input signal, the timer counter displays a 1 6 zeros, right? So that means right now we are in the timer mode. So when we are in the time mode, the display is time only, right? So what is the display? So he is saying that the display is 1,000 and again 000. So this is the time, but you are in the scale of nanoseconds. So that means whatever the reading you got, that should be multiplied by nanosecond, correct? If the scale is mentioned as millivolt, we need to multiply with millivolt. In millivolt scale, 100 is the display. Means what is the reading? 100 millivolt, correct? If microvolt scale, 100 is displayed, then what does it mean? 100 microvolt is the answer. Simple concept. So now we are in the time period, the scale is nanoseconds. So the display into scale, that is the final value, correct? So 1 into 10 power 6 into nanoseconds. So obviously what it will become? Basically in seconds it will be 1 into 10 to the power of 6 into 10 to the power of minus 9, I could say seconds. So this is equal to 10 to the power of minus 3 seconds. Clear? That is the time period. But now see, with the same input signal, that means the input signal is same, but the timer counter is changed to frequency mode. What is in hertz? What is the value of frequency in hertz? So when you change this to frequency mode, then the frequency will be shown to you, right? And frequency will be how much? 1 by t. So I could say 1 by t means 1 by time period, 1 by 10 power minus 3 seconds. Then it could be written as 1000 hertz here. Clear? So as it is mentioned hertz as the range, so I should say the answer as 1000 here. Clear? Such a wonderful question this is, right? So many people don't even understand the terminology here, but those who understand the terminology, it is a cakewalk. Just like that they can solve the question, right? So see, time period it is measuring, but the scale is in nanosecond. So whatever the reading you are having, that must be in nanosecond. Simple, number one statement. So that 10 power 6 into 10 power minus 9, so it is 10 power minus 3, that is easy. But when you are converting that into frequency, then the frequency is 1 by time period. Time period is already calculated as 10 power minus 3, that is equal to 1000 hertz. Now we are already in hertz. The range is set in the frequency mode as hertz. So as it is hertz, it is 1000 hertz, so the 1000 will be the answer. Such a beautiful question, right? How many of you really enjoyed and loved this question? Now there is one more question like this. In 2021, already in 2020 they asked this question, very few students have answered. Many students, they didn't understood the terminology, but in 2021 again the same kind of question was asked. Let me read the statement here. A 10.5 digit counter timer is set in the frequency mode, right? So if it is set in the frequency mode means the value what you are going to get is a frequency mode of operation with TS is equal to 1 second for a specific input, that is okay. The reading obtained is 1000. Good. So that means reading obtained is 1000. What is the range? So anyway it is set with 1 second means obviously it is hertz, right? So time is in second means frequency must be hertz here, right? Hertz, 1000 hertz. Without disconnecting this input, the counter timer is changed to operate in the period mode and the range is selected in microsecond. Clear? Microsecond. So that means when you go to the period mode, then first of all, what is the time period? So 1 by frequency, that is 1 by 1000. So I could say 1 by 1000 seconds it will become. So therefore, it has to be like 10 power minus 3 seconds. Correct? But it has to be put in a microsecond frame. How can we write this in microseconds frame? So this is equal to, I could say 1000, 10 cube microsecond. Clear? So 10 power minus 3 seconds is nothing but 10 power 3 microsecond. Just multiply with the 10 power 3 and divide with 10 power 3. 10 power minus 3 into 10 power minus 3 will become 1 microsecond here. And 10 power 3 will be balanced. So basically 10 power minus 3 seconds is nothing but 10 power 3 microseconds. So final answer is how much? So that means I could say now it will be showing like 1000 in microsecond setting. Clear? 1000 in microsecond setting means basically it is 10 power minus 3 seconds. What is the correct answer? Option D is the correct answer, and this is a fantastic question. Correct? So again, previous question and this question both are of same kind of question but very good questions, isn't it? So moving ahead to the next question, 2021. Right? So a 3.5-digit rectified type digital voltmeter is set. See, rectified type meter. They are saying that rectified type meter is set to read 2000 volt range. Very good. A symmetrical square wave of frequency 50 Hz and an amplitude of 100, okay, is measured using the meter. The meter will read dash. So very good. Square wave is given. One second. If the one second. Square wave. Sorry, one second. Square wave. What is the amplitude here? Let me write down. Square wave, and the amplitude was clearly mentioned as plus or minus 100. So let me take 100. Or as plus or minus also no problem. 100 volt. But it is a rectified type instrument. So it is a rectified type instrument. So I have to multiply with the factor because the final reading is final output is what? Final output, as it is the rectified type instrument, we have to multiply with the factor, that is 1.11 here. So it will be equal to plus or minus 1.11 volt. And those students who want to know how we are getting this, obviously you must go through the concept of rectifier instrument that I have discussed so elaborately in BYJU'S Exam Prep platform. In recorded lectures are already available. Go through the rectified type instrument from your mobile, download the BEP app immediately and go through these questions. In fact, go through these concepts, you will never face any problem in these questions. 1.11, right? Sorry, 100 into 1.11, this will be equal to 111. I'm sorry, 111. So if it is 111, then obviously 3.5 digit can easily show this one. How 3.5 digit can show this one? So you will be having like, right, 3.5 means 1 full digit and 3 half digits you are going to have, right? So if this is the reading, then it will show like this. Full bit, it will indicate 1, half digit again 1, and 0.0 will be there here. So like that it will going to see, right? 111.0 is going to be your answer. That is how we will be reading 111 volt here. Clear? So well, this is the completion. In fact, we have completed Q meters, CRO and DVMs also. Now it's the time to go for CT and PT. There are only 2 questions which were asked in electrical and instrumentation put together from the last 5 years of papers. So let me show the first question from CT and PT, that is electrical 2019. I would say this is a simple question. In fact, the total impedance of a electrical question, the total impedance of a secondary winding leads and the burden of 5 ampere CT, right, is 0.01. okay. So the secondary terminal has an impedance ZS is equals to 0.01 ohm. Nice. And if the fault current is 20 ampere, 20 times the rated primary current of the CT. So let me write down fault current, which is coming at the secondary side. So what is that value? So fault current is 20 times more than the rated primary current. So rated primary current is 5. See here, 5 ampere is the rated primary current, 5 ampere. So how much I could say? 100 ampere. The simple question, this is 100 ampere, right? Then volt ampere output of the CT is dash. So in fact, we need to calculate the power. Volt ampere of the CT means output power we need to calculate. Let me say output power here. Output power could be written as fault current. This might be the output current here. Let me say I0 square into the impedance, right? So I0 square into output impedance, that is ZS. So 100 square into 0.01 here, correct? So this will be like 100 into 1, of course, volt ampere, right? So therefore it is equal to 100 volt ampere. What would be the final answer? Simple question. This is 100 is the final answer for this question. And I hope many of you have completed this. Whenever you look this kind of questions, now you feel that these questions are difficult. But when you put on the paper, when you put down your pen on the paper, use a calculator, you will be getting the answer so easily. Clear? Last question of the day. In fact, last question of all previous year questions of measurement from 2018 to 22 is this one. So let me go with this one. A thousand into 1000 by 1 ampere, 5 volt ampere UPF bar, unity power factor. Very good. So first thing what I understood is unity power factor. Okay, right. So bar the primary measuring current transformer has 100 turns, sorry 1000 turns. So UPF, it is a unity power factor. So the cos phi equals to 1, right? So unity power factor means cos phi is equal to 1. The current transformer exhibit, one second, number of turns, secondary turns, that is equal to 1000 here. Very nice. The current transformer exhibits an error of minus 0.1% and a phase error of 3.438 minutes. Okay, phase error. So let me write down first of all, those students who attended my classes of CT and PT, I have explained each and every minute detail very clearly in the regular classes, like what do you mean by phase error, what do you mean by current error, everything I have explained, right? So the phase error is usually considered as a beta, right? So beta, he was saying that it is 3.438 minutes. So if you convert that into seconds, then it will be divided by 60. So what should I say? The beta value here all put together is how much? So just give me 1 second. 3.438 divided by 60. 0.0573. 0.0573 is going to be your beta. Very good. So the RMS value, 1 second. At this point, at this operating condition, the RMS value of the magnetization current, right, of the current transformer in amperes is dash. So people, magnetization current means what we require? We require I mu. What is the value of I mu? That is the question. Magnetization current. So again I repeat, I have already explained this concept so clearly in the recorded lectures. So if you want to understand what is CTPT from the basics, I suggest please go through the questions. In fact, go through the lectures on BYJU'S Exam Prep app. Well, so the phase angle error beta could be written as 180 by pi into, so 180 by pi, the moment when you write this one here like this, so this is something like 180 divided by radian, right? So it will be degrees per radian. So anyway, if you go with that, so what you will be getting here? So I mu into cos phi. So this delta is equal to 0. Why? Because it is a unity power factor, right? So if it is a unity power factor, I can say delta is equal to 0. That is, I told you that in fact here cos phi, instead of cos phi, let me take this as the angle here is going to be this one, right? So cos of this one, lambda. So that is equal to 0. So then what you will going to have here? So then I can say beta is equal to 180 divided by pi here. Very good, because already we are in seconds here, into, what should I say, the magnetization current, and this value I told you that this is 0. So cos 0 is 1. I mu divided by n into is here, correct? N into is here. So then everything is readily available to you, right? So I mu is equal to how much? So I mu is equal to beta into pi into n into is divided by 180. Every value is with you, right? So every value is with you. How do we write this one? Beta is equal to, what is the beta value? 0.0573. 0.0573 into 3.14 into 10 cube divided by 180, right, into is, secondary terminal current, secondary current. So the magnetization current will be equal to how much? Just multiply that, every one of you. All of you please multiply this. 0.0573 into 3.14, so there is a big value, divided by 180, right? So 9.93 into 10 power minus 3, so 0.9 you will be having here, so into 10 here. So obviously when you do the total calculation, if I am not wrong, 1 second, I am extremely sorry, yeah, just use the calculation of the secondary terminal here. 1 second, right? I need to get this slide back. 1 second guys, so please give me 1 second time. So we require in amperes what would be the current here, right? So use the secondary current from here. Already the specification is very well given here, right? So use the secondary current and put the secondary current value here and get what is the magnetization current. Just I am giving 0.1% work to you. I am very happy to see the answer from your side in the comment section, because everything I have done From starting to ending, each and every step I have completed. Just you need to use your calculators, multiply with the secondary rated current from here, and then you will going to get the answer. I am very eager to see the answer in the comment section, because already all the questions I have solved, all the questions entirely in the detailed manner I have solved. I am giving just one small minute calculation and I am expecting the answer from you. Please put that answer in the comment section. I will be watching again your answers after some time. I am very happy to see those students who are actually participating in the session. Clear? So well, once again I would remind to you, tomorrow we are going to start the marathon sessions. However, please connect to the channel such that you will going to get a regular updates related to each and every activity that is happening in the GATE domain. Clear? So with this, let me close the session, but before winding up the session, please do aware of the test series what we are giving every time. So the test series not only includes the subject wise test series, still you are having the full mock test also, full length mock test is there with the detailed solutions and even the video solutions also, correct? So all the way we are always one step ahead to give the best and quality content to the students. If you are so serious and dedicated, then BYJU'S Exam Prep is a single spot solution, in fact single stop solution to every sincere GATE aspirant. So guys, let me wind up the session. Hope this session is really useful to you and added a beautiful value in your GATE preparation. However, a simple question I have given as a homework to you, in fact single calculation, it's not a question. 99% I have discussed, 1% I have asked you to put down your pen on the paper and get the calculation done and give me the answer. Hope this session is really useful to you and you might enjoy it with me. So let's meet again in the marathon session, probably by day after, I mean tomorrow only, right? Tomorrow we are going to meet to have the marathon session on circuit theory subject, and the marathon session for circuit theory is from 4 p.m. to 8 p.m. So once again, all the best to you. Get connected to the BYJU'S Exam Prep channel and get live updates and participate in the sessions, get benefited out of these sessions. Thank you very much.